Hello, Algebra 2 students. In this video, we're going to factor polynomial equations. In class, we're probably going to do solving. So in this video, we're just going to focus on factoring. And we're going to look at polynomials with degrees higher than 2. So this is something you want to write down, the sum and difference of cubes. And I might warn you in this video, it's going to be intense. So you might need to step away for a bit. You might need to watch it more than twice. But this is huge. So yeah, lots of good stuff in this video. And yeah, take really good notes and be ready to ask lots of questions. Alrighty. So back to what I was saying with sum and difference of cubes, we need to write this down because this is how we factor when we're adding two perfect cubes together, and this is how we factor when we're subtracting two perfect cubes. So here's a list of perfect cubes if you want to write this down. You might know them already. If you don't, write it down. So let's look at this first example. We have 8x cubed plus 27y cubed. So what I like to do, using my little cheat sheet here, I like to find what A is going to be and what B is going to be. So remember, A and B are the cubed roots. Okay, so they're the cubed roots. So if we look at 8, what's the cube root of 8? It's going to be 2. The cube root of x cubed is x. Okay, so these are both the cube roots of what you have. Alright, so this is a cubed and this is b cubed, and we're going to be using the sum because we have an addition sign here. So b then, if we take the cube root of 27 is 3, and the cube root of y, or y cubed, is going to be y. Now I can just plug it in right here. So when we factor this, and we end up with 2x plus 3y. And then we have to square a, so it's going to be 4x squared minus, put these two together, times them together, it's going to be 6xy, keep it in alphabetical order. And then plus b squared, this is going to be 9y squared. And you can go ahead and distribute this and multiply this out to check, and you should end up with 8x cubed plus 27y cubed. All right, let's try another one. All right, let's look at this first example. We know this can be cube rooted. A could be 2y. But here, you can't really factor anything out. No GCF, so there's no GCF between the two. And 5 is not a perfect cube, so we can't really factor this down. So we're just going to say this is prime. We can't factor it down. Now let's look at this one. Now automatically we can't say prime because we don't see a perfect cube here. Let's see if we can find a GCF first. So we're always looking for that GCF, that greatest common factor. So between 5 and 320 we can take out a 5. And between y to the 4th and yz cubed, we can take out a y. So if we take that out, divide both of these by 5y. Now let's see what we get. So it looks like we're going to get y cubed minus 64z cubed. So y cubed then, we can, that's a perfect cube. So then a would be y. And 64z cubed, 64 is a perfect cube. The cube root of 64 is 4. So b then would be 4z. So let's go ahead and just factor this part right here. So when we do that, and I'll go ahead and leave the 5y out here, it looks like we're going to have, now this is a difference of cubed, so we're going to have y minus 4z. And we'll have y squared because it's going to be a squared plus ab, so we're going to write plus 4yz, keeping it in alphabetical order. Looks like I'm going to have to move some stuff over here. because I'm running out of room. And our last term is going to be b squared, so this is going to be 16 z squared. And that will be our final answer. We can't forget about the 5y that we factored out in the beginning. So here are some factoring techniques. Feel free to write these down. We're really going to focus on these right here. And difference of squares we haven't really gotten into a whole lot of yet. But there is a rule for this. You did see it in Algebra 1. And we have done it, we just haven't used the rule, I guess. And grouping, we're going to come back to grouping. And GCF, we always look for the GCF first off. So feel free to write this down if you need to. So here's an example of factoring by grouping. So I'm going to go ahead and group terms that I see that are alike. So for example, these three terms, they all have x in common. And they all have a 4 in common. So if I take out 4x, I'm left with 2a plus b plus c. Now is there something I can factor out from these three terms to end up with 2a plus b plus c? Yeah, I could factor out a 3y. And so remember with grouping, we put these two terms that are on the outside, we put them together. And then whatever we're left with, we just write it once because we're factoring that out. And so that would be our answer. All right, another example with factoring. We have x to the 6th minus y to the 6th. Notice these aren't squares or cubes, but is there a way we can write it as a difference of squares? We always look for difference of squares first. So can this be split up into two terms? Sure it can. It can be split up into x cubed and x cubed. And this one can be split up into y cubed and y cubed. So we're always looking for that difference of squares first. If that doesn't work, then you can use your difference of cubes. So if we look at our rule, it just says that we're taking a. So a would be x cubed and b would be y cubed. So again, looking at difference of squares, it ended up being x cubed plus y cubed times x cubed minus y cubed. And that would be our answer when we factor it. So you have to be creative. You have to be very, very creative. All right, here's some more factoring. So again, we have lots of terms, so let's see if we can group these terms together. Pause the video, see what you can come up with. All right, so right here I'm looking at these terms. I notice they all have an a cubed that you can factor out. So I'm left with x squared minus 6x plus 9. And this one right here, I'm going to go ahead and take out a b cubed, a negative b cubed actually, because there's this negative out in front. And I want to be left with the same right here, the same terms. So we have x squared minus 6x plus 9. If I divide everything by a negative b cubed. Okay, so that's how I get those signs. We want these two to be the same. So I'm going to go ahead and put my a cubed minus b cubed together. And then I'm left with x squared minus 6x plus 9. Can this be factored? It sure can. We're going back to Argyle right here. So we have a negative 3 and a negative 3. So we have x minus 3, that quantity squared. So I just factored that. Now a cubed minus b cubed, can that be factored? Yes, it can. We can actually use our shortcut. And what do you know? It's the same as what our shortcut says since we have a and b. That's funny. So since it's the difference of cubes, we're going to use a minus b times a squared plus ab plus b squared. And we still have this guy out here, so we're going to tack him on, minus 3, that quantity squared. And that is our final answer. So lots and lots of factoring we're going to be doing in this next section. Again, rewatch this video if you need to. It is intense. We're going to practice solving in class. Come with questions, and yeah, don't get discouraged. We'll see you later.